Hello all data science learners. Today we are again with another video on the topic of logistic regression modeling. So in logistic regression modeling we will be covering logistic regression and Poisson regression. Logistic regression is basically used for classifying problem. Although its name contains regression, but is it used for classifying problem because its name is because it is a extended form of linear regression. So let's move to its in-depth explanation and implementation. So let's move to the coding screen. So logistic regression. So logistic regression is used for binary classification where we use sigmoid function that takes input as independent variable and produces a probability value between 0 and 1. A logistic regression model transforms the linear regression function continuous value output using a sigmoid function which maps any real valued set of independent values input into a value between 0 and 1. This function is known as logistic function. So basically the output of the linear regression is converted into a value from 0 and 1 using sigmoid function. So a sigmoid function, what is a sigmoid function? So sigmoid function is a mathematical function used to map the predicted values to probabilities. It maps any real value into a range of value from 0 to 1. So the curve formed for this logistic regression is of a shape S and is known as logistic function or curve or sigmoid function. So now let's move to the implementation part. So first of all, I have imported all the required libraries: pandas, numpy, matplotlib and seaborn. Then we are importing a make classification function from the sklearn library because we need to create a data set for this model explanation. So first of all, I am making a sample of 1000 words and I have taken 10 features and classes it's 2. So the output will be 0 or 1. So now we are doing trend test split and I have taken the test size as 0.33 and now I have imported logistic regression from sklearn. So now we will fit this x trend and y trend on logistic regression, and then we will predict the outputs using predict function. So here we are printing all the predicted values. So you can see that 0 and 1 is the only output, as we have used classes equal to 2. So the y will contain only 0 and 1. So here we have predicted it. So now let's evaluate our model. For this I am importing accuracy score, classification report and confusion matrix from sklearn.matrix library, and let's print the score. So accuracy is 0.96. It is quite good, about 90% it is accuracy, and the precision is also 0.9340 and 0.90. Recall is 0.91 and 0.92. F1 score is also quite good. So overall this all are above 90%. So our model is trained nicely, and this evaluation can be concluded that this is a nicely trained model with an accuracy of above 90%. So in this there is another regression model which is known as Poisson regression. So Poisson regression is used when we want to predict a count of events, such as how many times a customer will contact customer service. Distribution of response variable will be a count of occurrence with a minimum of 0 value. So here the output will contain the counting for a particular event to occur. In probability we had the occurrence of a particular event. So here also, and here the minimum value of the counting will be 0 for a particular event. And for this we use Poisson regression class from sklearn.linear model. So again here we are creating a database using numpy random function. This will allocate random values to x1 and x2 these values will be between 0 and 1, and the number of entries we required is 100. So this is the independent variable, independent features, and then we are having a dependent feature, that is np.random. Using np.random.Poisson, we are getting a dependent feature, that is y. Then we are creating a data frame named data, and we are getting a x as an independent set of independent features, x1 and x2, and then we are using Poisson regression to fit this Poisson regression model on x and y data set. So now we are making predictions. So we are predicting the value of y on the basis of value of x, and there we are predicting the predictions. So let's run it. So now you can see here the outputs, all the predictions which we have get as an output from this code. So here you can see that it is 0.555, it is 1, it is 2. Basically it is greater than 0, it is not negative. So this is the count of a particular event to occur. So this is very useful in cases like for predicting customer care service, for predicting the number of customer coming to a customer care service, and in many more situations where we required counting of a particular event. So this was all for the regression. Thank you, and have a nice day.